This is Malik and welcome to our lessons on vectors and bearings. So we want to look at distance bearing problems. Right. So right from introduction to bearing, compass bearing, 3-point bearing, bearing from one point to the other, back bearing, what we did, all the previous lessons was to actually drive us to the main objective of this particular lesson on bearings. And the main objective is to be able to solve distance bearing problems, right? And we have steps here to follow. And the first step is to draw a rough diagram of the positions of the points concerned. So right after reading the question, just draw a rough diagram. And the second step is to be able to form a right angle triangles from the diagram that you've drawn. And then the third step is to be able to apply the trigonometric ratios and Pythagoras theory as appropriate to be able to solve the question that has been given you. So let's look at examples and see how we'll be able to apply these steps. Right, so we have 4 examples. I will do example 1 and 3, then you do 2 and 4. Right, so let's look at this first example. It says the bearing of x from y is 70 degrees. And the bearing of z from y is 160 degrees, where x, y, and z are 3 points in the plane. If y is equidistant from x and z, find the bearing of z from x. Right, so we will begin with the first statement. It says the bearing of x from y is, and as I always say, the position that always comes from after the word from is where you begin from. So it means x from y is 70 degrees, meaning our first position is y, right? So that's the step 1. The step 1 says draw a rough diagram. So the first step we will need to do is to draw a rough diagram. Therefore, I have to just come. I just got to come here, and I'm drawing my rough diagram. So I'm starting from y. So I come to y. This is my y. I'm drawing my position. So this is my position y. And it says x from y is 70 degrees, right? And I know the first quadrant is where I will get my 70 degrees from because I know this is my 90 degrees. So if I want 70 degrees from the north, it has to be more than half, right? So when I open almost more than half, so I'm going to take this to be my 70 degrees. And it's saying to x, right? 70 degrees to x. So it moved all the way 70 degrees here to x. So this is my position of x. This is my x. And it's saying it was 70 degrees. So this bearing is 70 degrees, right? So I'm done with that part. Now let's move on to the next one. It says the bearing of z from y. Z from the same y. This is our y. And it's saying looking for z from y is 160 degrees. So I'm going to go back to the same y. I'm looking at the same y and I'm looking for 160 degrees, right? I know from the second quadrant here is going to be 180 degrees. So if I'm looking for 160, it's going to be between this. It's going to be between the second quadrant here, right? So from 90, how much more do I need to add to 90 to be able to get 160, right? So it's just going to be 160 minus 90, which is going to be 70. It tells me that in the second quadrant as well, I need 70 more because I want 160. So from here, I want 70. I'm going to go more than half again because I need 70. So, and that is moving to z. So, sorry. So let me go back to that. I want 70. So 70 is going to go down. right? And I'm moving to what? Z, because that's to the point Z. So this is my Z. I draw another Cartesian plane there, right? So this is the point Z. The first step is for us to draw a rough diagram. So this particular one is also 70 degrees because I want 160. So it tells me from the whole of the north here, when I move all the way here, from all the way to Z, it's 160 because I got 70. So the whole of 90 plus 70 is going to give me what? 160, right? Okay. All right, so now let's look at the last part. What does it say? Let's look at the question. When I go back to the question, it says, where X, Y, and Z are 3 points. So we already got our X, Y, and then our Z. If Y is equidistant from X and Z, it tells you that Y is of equal distance. The point Y, let me use this. The point Y is of equal distance from X and Y. So the distance from Y to X is the same as the distance from Y to Z. That's basically what it means, right? So we now have this, and it says, right from this, so we know automatically we are forming a triangle, a right angle triangle. So I just got to join this. I'm joining this to form a right angle triangle, right? So from the first step, it says, just do a rough diagram. And we have our rough diagram, right? So the second step, what did the second step say? Let's move on to the second step. It says, form right angle triangle from the diagram. So automatically, we now have our right angle triangle, right? We have our right angle triangle from the diagram. Now, realize that now the red one shows a triangle. But want to see the red one, if you look at it carefully, you now have a triangle. But is it going to be a right-angled triangle? A right-angled triangle is one of the part of the triangle is going to be 90 degrees. So we want to find out which of these is going to form a right-angled triangle. We want to see, can we get a 90 degrees angle? Now, let's pay attention here. When you look at this particular spot, I'm going to look at the first quadrant. Let's pay attention to the first quadrant, right? So let's pay much attention to the first quadrant. So I'm paying attention to this quadrant. Look, I'm going to deepen it. Let's look at that particular quadrant, right? You realize that the whole of that quadrant is supposed to be 90 degrees, but this angle here is 70 degrees. So how much more will it add to 70 to be 90 degrees? So it tells you that the remaining angle here, the small angle there is 20 degrees. Because 20 plus 70 is going to be 90. Right? Okay. So now we know that particular space that was left is 20. So now we want to look at the total angle that is going to be formed in here. So let me use another marker here. Now we want to look at the total angle that is going to be formed here. This one. What is going to be the angle there? The angle there is going to be the 20 here plus the 70 that we have here. And 20 plus 70, 20 plus the 70 is giving us 90. So it tells us that inside that triangle that we have, one of the angles is 90 degrees. And since one of the angles is 90 degrees, it tells us it's a right-angled triangle, right? So now I'm going to go to the second step that says form a right-angled triangle. So automatically now I have my right-angled triangle like this, right? So if I have a right-angled triangle, it tells me this part is 90 degrees, which we formed from here, right? And the right-angled triangle is at Y. So this is my Y. Remember, this is our X, and this is our Z. So now you have something like this, which is the second step. Because the second step says, let's look at the second step. It says form a right-angled triangle from the diagram. So you've already been able to establish that you've been able to find a right-angled triangle. Right, and from the question, it told us that this particular line and this line are the same, right? So if it's a right angle triangle, and we know the total area of the total interior angle of a triangle is supposed to be 180, right? So we already established that this part is 90 degrees. So how many is left? You just left with 90, because 90 plus 90 is going to give you what? 180. So automatically, this part here is 45 degrees. And this is also 45 degrees, right? So we are going to bring this idea here. I'm just going to bring what we've been able to establish here to this particular diagram so that you don't get confused, right? Right. Okay, so here we now have our 90 degrees here. Let me use this particular one to establish the fact that we now have our 90 here. We know the whole of this part. The whole of this part is also 45 because we have it here. So this is also 45 degrees, right? So it will tell me that the whole of this part, the whole of this is also going to be 45. But then remember, we have two angles there. So how do we know which one is 45? Because we know the whole of that is 45. But we have to divide it into two because it has been divided into two. So now, I'm going to go back to and use the alternate angles idea. Look here. If this is 70, if this particular part is 70, remember this angle alternates with this angle. So if this is 70, it tells me this is also going to be 70 degrees, right? And the whole of that angle is supposed to be 90. Therefore, if I've taken 70 out of it, it tells me that the remaining part, this part, is 20, right? So if 20 has been taken out of it, let me extend this. We've already established from here that the whole of that is supposed to be 45. So 20 has been taken out of it, meaning the remaining part here is going to be 25 because 20 has been taken out of it, meaning this is 25 degrees, right? So if this is 25 plus 20, that's the whole of that is 45, which goes to confirm this, right? Now we want to look at the main question told you that, look, find the bearing of Z from X. It means that if I'm at X and I want to turn, this is my north, this is my 90 degrees, this is my 180 degrees. If I'm at X and I want to turn, I want to make a total turn all the way to look at Z. Because if I had to turn, make that whole total turn to be able to look at Z down there. Now, from this all the way to this part is 180, meaning we have to find just the little angle that is left. And that particular angle alternates with the angle that we just solved here, which is 25. So if this is 25, it tells me this angle left, the angle left here is also going to be 25 degrees. Therefore, the total turn that I have to turn is going to be 180. This 180 plus the 25 degrees that we have there, right, which is going to give you 205 degrees. So you can now say that the bearing of Z from X is going to be equal to 205 degrees, right? So you just have to take your time, look at the video, rewatch it, and it's going to make a lot of sense to you guys. So I'm going to give you the second question, which is number 2, to solve it.